Hello students, today we will do numericals based on lens. Okay, so let's start. First question. A 5 centimeter tall object is placed perpendicular to the principal axis of convex lens of focal length 20 centimeter. The distance of the object from the lens is 30 centimeter. Find position, nature and size of the image formed. So what is given in the question? A 5 centimeter tall object. Height of object is 5 centimeter. Now focal length of convex lens, we always take focal length of convex lens as positive. Whether it is mirror or lens, when it comes to convex, it is positive. Focal length is always positive. So f is equal to plus 20 centimeter. Distance of the object from the lens. We are talking about object distance, which is 30 centimeter. Object distance is always negative, so u equal to minus 30. You need to calculate v, you need to know the nature, you need to know the size of the image. So let's see how to solve this. So as we discussed, height of object is 5 centimeter, u is minus 30, f is 20 centimeter. We need to calculate v. We have lens formula, 1 by f is equal to 1 by v minus 1 by u. You need to calculate v, right? So let me shift 1 by u to this side. So 1 by v is equal to 1 by u plus 1 by f. Substitute the value. Okay. So when you substitute the value, what do you get? 1 by 30 plus 1 by 20 is equal to, okay, here what happens, this is 1 by u, it's 1 by minus 30, so minus and minus plus. So when you shift it here, this has to be minus. Here it will be minus, okay. Here it should be minus. So the LCM of 30 and 20 will be 60. So minus 2 plus 3. I mean this part here, when you shift u, this becomes minus 1 by 30. This is minus 1 by 30. Okay. There's missing of a negative sign there. So minus 1 by 30 it is. So minus 1 by 30 plus 1 by 20 gives you, when you take the LCM and solve, you will get 1 by 60. Okay. So V becomes 60 centimeter. So now we know the position is 60 centimeter. Now let's see what the nature will be and size of the image. So for that we have magnification, which is V by U. Substitute करो. ठीक है, यहाँ भी minus 30 आएगा, तो 60 by minus 30 will give you minus 2. यहाँ पे एक माइनस मिसिंग है, दिस इज minus 30. ठीक है, u क्या है, minus 30. सो minus 30 इक्वल टू minus 2 आएगा. सो हाइट ऑफ इमेज बाय हाइट ऑफ ऑब्जेक्ट क्या हो जाएगा, -2 हो जाएगा, जिसमें से हमें ये पता है कि हाइट ऑफ ऑब्जेक्ट इज 5. सो व्हेन यू शिफ्ट दिस हाइट ऑफ ऑब्जेक्ट टू RHS पार्ट, आपको क्या मिलेगा, -2 इंटू 5 विच इज -10 सेंटीमीटर. -10 सेंटीमीटर मतलब वो प्रिंसिपल एक्सिस के बिलो है हाइट, मतलब नेगेटिव, मतलब इट्स अ डाउनवर्ड डिस्टेंस. तो ये क्या हो जाएगा, इमेज इज रियल एंड इन्वर्टेड. ठीक है, so real, inverted and magnified image. Since you're obtaining it on the screen, it is not erect, it's just below the principal axis, so it has to be real, inverted and magnified. Okay, so now let's see the next question. A 5 centimeter object is placed perpendicular. 5 centimeter object in the sense height of object is perpendicular to the principal axis of convex lens. Again, focal length will be plus 10 centimeter. The distance of the object from the lens, that means object distance is minus 15 centimeter. Find the position, size and nature of the image formed. Very similar to the earlier ones. I'm sure you can solve this, right? So using lens formula, substitute the value. 1 by f is equal to 1 by v minus 1 by u. So you need to calculate 1 by v. Substitute the value, you get v as 30 centimeter, taking the LCM. So magnification is v by u. When you substitute v and u, you will get -2. So height of image by height of object क्या हो जाएगा? V by u is also equal to height of image by height of object, right children? So substitute the value, you get height of image as -2. 10 centimeter. So the image is real, inverted and enlarged. Alright, you can stop the video and solve and then check your answers here. Alright, very similar one. Now let's see the next question. Okay, so this is about concave lens. So a concave lens has focal length 20 centimeter. So focal length of concave lens is taken negative. So f is equal to minus 20 centimeter. Okay, at what distance from the lens a 5 centimeter tall object be placed? So height of object is 5 centimeter. So at what distance object should be placed? That means they are asking you to calculate object distance so that it forms an image at 15 centimeter from the lens. So image distance is given as 15 centimeter. Concave lens it is. So image is always virtual and erect. So image distance V needs to be taken. Virtual and erect in the sense, where is the image formed? On the same side as that of object, right? So V will be negative here. So calculate the size of the image. You need to calculate height of image. So how will you calculate? Using lens formula, you will get U. Just substitute the value. So U will be 1 by V minus 1 by F. Substitute, solve, you get U as minus 60 centimeter. So height of image by height of object is also equal to V by U. So height of image will be V by U into height of object. Substitute the value, you get a height of image. So height of object is 5 centimeter, height of image is 1.25 centimeter, which clearly gives you the idea that image is diminished. And we know it's virtual because it is concave lens. Okay. So image is diminished and virtual. Easy it is. If you know sign convention, you can easily solve the numericals. Fine. Now let's see the next question. Okay. A convex lens has a focal length 10 centimeter. Okay, convex lens, so focal length 10 centimeter in the sense plus 10 centimeter. Okay. At what distance from the lens should the object be placed so that it forms a real and inverted image 20 centimeter away from the lens? So that's image distance. Image is real and inverted, that is why we are taking V as positive. Okay. Then it says, what would be the size of the image formed if the object is 2 centimeter? So height of object क्या हो गया 2 centimeter. तो लेंस फॉर्मूला यूज करो तो उसमें u आ गया, सब्सटीट्यूट द वैल्यू u आ गया. ठीक है. अब जहां पे, अब ध्यान से देखो, इमेज डिस्टेंस एंड ऑब्जेक्ट डिस्टेंस इज सेम. One is this side, the other 20 centimeter is that side, the principal axis. So that means if the distance is same, we are talking about which case when the object is placed at 2f. So when the object is placed at 2f, we get image at 2f, right, on the other side of the lens. So height of the image will be equal to height of the object. So you need not solve. So height of object क्या दिया है 2 centimeter. तो height of image भी क्या हो जाएगा 2 centimeter. Easy it is. Okay. Now let's see the next question. A concave lens of focal length. Again, concave lens, focal length is negative. So 15 centimeter minus 15 centimeter forms an image 10 centimeter from the lens. Image distance is 10 centimeter. V is negative. Why? Because we have image on the same side of that object. You need to calculate U, you need to calculate M, and you need to tell the nature of the image formed. Easy, using lens formula, right? So, position of the image. How do we get to know the position of the image is between focal length and optic center? That's simple because focal length is 15 and image distance is 10. That means image is formed between focal length and optic center. So we know the nature, that is virtual, erect and diminished. So using lens formula, substitute the value, take LCM, you will get U as minus 30 centimeter. Okay, magnification will be minus V, this is lens, so it will be plus V by U. Substitute the value, you get 1 by 3. Since magnification is positive, so image will be erect. Okay, since V is negative, image is virtual, same side as that of the object. And M value is less than 1. When M value is less than 1, that means image is diminished. Okay, so height of image is less than height of object. Alright? Very simple ones. You just need to know, I'm repeating again, you just need to know sign convention. Okay, now let's see the next question. The image of a candle flame produced at a distance of 45 centimeter from the lens. So 45 centimeter from the lens is formed on a screen placed at a distance of 90 centimeter from the lens. Screen is placed at a distance of 90 centimeter. So that is image distance, right? So 45 centimeter becomes object distance. You need to check what type of lens it is. You need to calculate focal length, and height of the flame is given as 2 centimeter. But identification is not difficult. Why? Because screen is placed, that means image is obtained on screen, right? So it has to be convex lens. Okay, so using again lens formula will solve this. So we know the name of the lens, which is convex. U is minus 45, V is plus 90 centimeter, because it is you are obtaining it on the screen, and height of object is 2 centimeter. So using lens formula, substitute the value, you will get the focal length. Okay, so first part of the question is clear. Then you need to calculate height of image. So we know height of image by height of object is V by U. Substitute the value, you'll get to know the unknown value. So height of image is 2 into 90 divided by minus 45, which is minus 4 centimeter. Since height of image is minus, it is real and inverted. Okay, I hope these numericals are clear to you all. We'll give you a few more questions for practice.